My guest is Ed Huling, an organic farmer and the founder and chief technology officer of Forterra. That's the number four TERRA.eco, a company with breakthrough soil restoration and reforestation solutions that will help address climate change and feed more people while increasing the value of farmland. Ed, thank you so much for joining me.
I appreciate the invitation.
Your website says we are restoring soil fertility, helping cool the earth, and increasing land value. That's a lot to do all at once. How do you do that?
Well, if what I might do is just give just a little bit of background that helps inform and will ultimately help answer your question, is that I set out about 25 years ago working at the USDA, researching the connection between soil fertility and food nutritional value, and specifically the loss of food nutritional value. And what became clear is that soil nutrient density and organic matter and biological diversity has declined dramatically over the last 100 or more years. Certainly here in the United States, but also globally. And it's this decline in nutrient density and all these characteristics that led directly to a loss of nutritional value of our food today compared with, let's say, 100 years ago, when I was able to find research, published research that showed analyses of food nutrition back 100 years ago. So long story short, I left the USDA to work on commercializing a way of restoring soil fertility, nutrient density to improve food nutritional value. It turned out to be much more complicated than I expected. It took about 15 years to do this, but we ultimately were able to have significant amounts of 24 different vitamins and minerals in the food that we were growing, and USDA allowed us to publish this on our label. But what happened along with the restoration of soil that allowed us to increase nutritional value is that we were able to produce much more food per acre, so that the soil was much more productive. And about 7 years ago, my daughter expressed deep concern about the future impact of climate on her life and the life of her children. So I began to consider the relevance of soil to the climate, the climate crisis. And it turned out that soil is actually foundational in this climate crisis. And the reason is that forests are hugely important in how the earth cools itself. The evaporation from trees cools the region of the forest, and on a global basis makes a major contribution to converting solar energy to latent energy contained in water vapor, which is then rises up into the atmosphere, condenses, re-radiates that energy back out to space. So what has been happening really over the past 10,000 years is that humans have been cutting trees down to make farmland, but then soil is actually depleted, so that we need to go cut more trees down. So we're at the point now where, according to the IPCC, 46% of the land area on Earth is now desert or arid wasteland, so unable to reliably produce food. So this 46% at one point was largely forested, cooling the Earth, and we no longer have that giant air conditioner helping to cool the Earth. So in order to, although reducing CO2 from the atmosphere is certainly an important objective, because CO2 is helping keep heat in the atmosphere, restoring forests and avoiding the continued deforestation is a critical part of fighting climate change. And so since 80% of the driving force on deforestation is growing more food to feed a rising population and overcome soil degradation, the way that we stop deforesting is by restoring soil. So that's how we circle back to the soil issue. So that's what we're doing at Forterra, is working. At the moment, we're focused on abandoned coal mines and other types of mines, because you've got well over 1 million acres in Appalachia alone of land that is just completely unproductive. And we found that with our soil amendment that we can turn unproductive mine land into productive farmland. So boosting our ability to produce more food without cutting more trees down. So that is the key. We also find in the research we've done applying our soil amendment to trees at different ages, that we increase tree growth by at least 200%. So we can reestablish forests more quickly, healthier forests with our soil amendment.
You're able to, let me go back to the website. It had another couple of interesting things. It says, our fertility amendment contains beneficial microbes, minerals, and organic matter that boost crop yield and farm income. So what can you tell me about the story of taking the time to develop this soil amendment?
Yeah, when I started out on this quest 25 years ago, I really had no plan. There wasn't a book that I could read. How do we restore food nutrient density? Farmers were generally focused on, certainly organic farmers were focused on eliminating toxic pesticides from food, which is certainly an important objective, and as an organic farmer, one that I adopted myself. But clearly, there were other things needed in order to restore food nutritional density. And so really, it took a number of years before I was even able to find what are the factors that increase food nutrient density. Certainly, if soil had such a low level of a certain mineral, copper or zinc or selenium or many other minerals, certainly, obviously, you're not going to find it in the food that's grown in that. And that is a condition with our soils. And in many cases, depending on the location, one location you might have extreme low zinc, another location you might have extreme low selenium. And so the food is going to be deficient in those minerals. So it took time to develop the means of restoring those minerals. One of the complicating factors is that at the end, each of these minerals has to be present in the right ratio to each other. Otherwise, the plant will tend to preferentially take up too much of one mineral and kind of drown out the other mineral. So it certainly was it took hundreds of experiments with different ratios of concentrations of these different minerals to get the concentration where the plant was happy to take up significant quantities of all the elements. Because certainly trace elements like zinc, they're going to be available in very low concentrations, but the human body doesn't need much of these trace elements. But in farmland that has almost none of these trace elements, the food has no meaningful amounts of these elements, and it's reflected in the increasing presence of chronic diseases. Back in 1980, the healthcare costs in the United States were $200 billion. Today, they're $4.3 trillion. So over a 40, 45-year period, while population has perhaps doubled, you've increased astronomically the healthcare costs, and the lower and lower concentrations of these essential minerals is one of the factors. It's not the only one, but it's an important factor in human health. So at the end, we found that there were three major areas that needed to be addressed in order to restore food nutritional value. Certainly the presence of minerals and the proper concentration, but since the microbes in the soil are intimately involved in all aspects of plant metabolism, plant health, plant immune system, intermediation between minerals in the soil and transforming them into a form that plants can take up through their roots. The microbial diversity in the soil is key as well, and that has been destroyed to a large extent by farm chemicals, by plowing, by depleting essential minerals. So it took us years to develop ways to restore this microbial diversity. And then finally, organic matter in the soil. I knew at the USDA that this was essential, but since many types of organic matter that are applied to soil simply oxidize on the surface and don't remain available in the soil to boost organic matter, finding methodologies for boosting the carbon content, the organic matter in soil, was significant as well. So took time to do all this, hundreds of experiments and testing and lab testing.
When it comes to the microbes, do you nurture the ones that are already there, or do you have to bring them in from elsewhere?
There's some debate about that. I was fortunate in studying with Dr. Elaine Ingham, a soil microbiologist, and learned many important things. But I ended up departing from her, what she taught, which was that the microbes are in the soil. We just need to change the way we farm so that the good microbes are supported and the bad ones, are marginalized. I found in the end that there simply isn't the diversity that is needed to get full productivity of the soil, that we actually had to find sources of microbes and restore microbes that are missing. And we needed to change the way we farm so that we are supporting the beneficial organisms.
Tell me about the results that you've been able to get in both crops and livestock.
Yes, we did a demonstration project with a professor at Princeton and a professor at the University of Vermont, monitoring our results, and we've done multiple trials over the last 6 or 7 years, moving from the greenhouse where I spent the whole developmental period during the 15 years of enhancing food nutritional value. Over the past 6 or 7 years, we've been focused on adapting what we've learned in the greenhouse to field agriculture so that we can have a bigger impact on climate. And research projects we did here over the last several years, we got up to a 600% increase in the productivity of forage grasses with our amendment compared to control plots that did not have our amendment. Another project, we got a 300% improvement during a severe drought in New Jersey, measured by Dr. Eric von Wetberg. We also, in the lab results from the Princeton scientists, they found that we had increased the protein content of our forage by 50 to 100%. And that had a direct impact, along with the increase in trace minerals that that are taken up by the forage, that cattle eating our forage gain 100% more weight per day. So we're seeing, on average, 3 pounds a day cattle weight gain, rather than 1.5 pounds, which is more typical for grass-fed forage animals.
I was going to ask you how you add to the value of the land, but there it is right there. If you can get double the weight gain per day, you've got more, you get 600% improvement in forage grasses. I take that to mean maybe a 7 times improvement in the rate of growth of the grass. Protein is double per unit volume, maybe by dry weight of the forage. And then you've got more trace minerals, which not only adds to the nutritional value of the meat, but also I would assume it adds something to the taste.
The people processing the meat that we produced were very positive about the flavor and eating value of the meat that we produced. Absolutely. The minerals actually also affect the metabolism of the animals, so that when you get better carbohydrate metabolism and better, for example, most farmland is very low in cobalt, and cobalt is essential for producing vitamin B12, and vitamin B12 has a lot to do with how animals convert feed to meat and muscle and bone and everything. So the minute you increase cobalt in the soil, you improve, as well as chromium, you improve animal metabolism, so that they're actually converting more of the food they eat into body mass and muscle and bone, and flavor, as you mentioned. So yes,
well, this seems like a no-brainer. If I'm a farmer, I have land, and then I want to immediately find Ed Huling and buy whatever you have.
We would think so. It does. Our amendment represents a major amount of material, and relative to the normal yearly expense for fertilizer, it is a significant increase, and so that is an issue for most farmers that simply don't have. Effectively, what is needed is to replace what has been extracted from soil over the past hundreds of years. And our program, we do this in one application, year after year after we apply our amendment. The plants are sequestering more and more carbon from the atmosphere and building up soil carbon via the root exudates that are produced in the plant and transferred into the soil. We've found that we increase soil carbon much faster than most than other farming systems. So we make a major investment in the soil as a one-time application, and then the plants and the farming system are improving the soil year after year after that, instead of what most farming systems are actually oxidizing soil carbon, killing off microbial diversity, and depleting minerals. We provide a major 10 ton per acre application that provides a real storehouse of minerals and to improve soil over time.
So you're talking a lot about soil carbon. Farmers and gardeners have been taught to add NPK, nitrogen, potassium, and phosphorus. And so what is soil carbon, and are we talking about a different understanding of how to get soil fertility?
There certainly are differences in opinion about that. I think a lot of what I learned in early years of organic farming was that by applying organic matter composts, I would increase my soil organic matter. And the research shows that over a period of years, there is a very small increase in organic matter. But what I found is that the vast majority of compost and organic matter that I applied to the soil just oxidized, were consumed by soil bacteria, and I was left with nothing 3 or 4 months later, and I had to do it all over again. So what we have found in recent years is that by restoring soil to optimize plant growth and microbial diversity, mycorrhizal fungi in particular, that we're able to increase our soil organic matter, not by what happens on the surface of the soil, but by what happens via the plants and the plant roots, and so that we can increase soil carbon. And all farmers know that soil carbon is vital for storing rainwater, for storing minerals, for providing an aerated structure, for improving permeability to hard rains. That organic matter is essential for all those things, and farmers are generally as protective as they can be. But since 95 or more percent of all farmers are using chemical nitrogen fertilizer, and it's been proven, there's scientists out at the University of Illinois that have proved over the last 20 or 25 years that chemical nitrogen fertilizer boosts the growth of bacteria that consume organic matter. So while they're on one hand trying to do no-till and do cover crops to boost their soil carbon, most of them are still using a chemical nitrogen fertilizer, which actually boosts these microbes that consume organic matter. So they end up with very low, if any, increase in carbon year after year. And so the first thing is to look to nitrogen fixing crops, alfalfa, peas, beans, that are taking nitrogen from the atmosphere and building soil nitrogen with nitrogen fixing bacteria and plants to get away from the nitrogen fertilizer. So that's an important step, and restoring microbial diversity is another key factor, and boosting plant growth is another one.
How important is plant diversity in that mix of strategies?
Yeah, we have found, whether we're talking about forage or we're talking about trees, research that we rely on, for example, with trees, show that forests with 20 or more tree species literally sequester 100% more soil carbon than a single species tree plantation. So that's an example. But there's it's well known that increasing crop diversity also increases productivity of whatever crops are being grown. I'm not sure how much. I can't think at the moment of research that's connecting carbon sequestration with different crop diversity, but certainly this research has been done with trees, and we know that that increasing plant diversity increases productivity.
What have you seen? You've mentioned increased tree growth, I think, so can you talk about some specific results that you're getting, and what's the alternative? Let's say you engage a landowner, an owner of forest land or potential forest land, and they're thinking about planting a pine plantation, but you recommend something a little different, and what results are you seeing?
Yes. First of all, I should clarify that, I've spent most of the last 25 years as a vegetable farmer, and the last 5 years or so focused on developing a more climate supportive meat production system. The experiments we've done with trees are pretty dramatic, but we haven't had much resources, and so we haven't done extensive research on reforestation.
Mm-hmm.
We're just forming a partnership right now with a forester, and we're looking forward to doing much more work. And we've also done projects with silvopasture. So we feel that this is an important change that needs to be made with grazing and animal production, is that by incorporating trees into the pasture area, you're providing shade to animals, which is more and more crucial as temperatures increase. But we're increasing planet cooling because of the evaporation from these trees, and we're sequestering and storing carbon from the atmosphere. So there's just many reasons to plant more trees, and it reduces productivity of the pasture very little if the trees are positioned correctly so that you get sun to almost the full pasture area. It just has many, far-reaching economic and environmental benefits.
Yeah, I know a farmer who went to considerable expense to cut down and remove cedar trees and black locust trees in the pasture. And I'm thinking maybe you didn't need to remove all of them. Maybe leaving some of them there would provide some benefit.
Yes,
Go ahead. Go ahead.
Yes, one of our advisors is Dr. Brett Chedzoy from Cornell, and he's been working on silvopasture for 30 years, and it works with farmers so that when they want to clear more pastures, clear forest for more pastures, he helps them leave the appropriate number of trees so that you get all these benefits without wiping out all the trees. So you're exactly right. The trees are a good friend to animals and farmers.
Yeah. Well, I'm trained with the Savory Institute in ecological outcome verification, and we look at 4 functional groups of plants, including the trees and shrubs, with the idea being that you, in your plot that you're monitoring year to year, you want to see, holding constant for other factors, you want to see trees and shrubs. That's diversity for one thing, and that's
Absolutely.
potential shade. And diversity is going to be good for your soil. Anything that's good for the soil is good for the life in the soil, and so forth, which ultimately is going to be good for those varieties that the cattle eat. Plus, some trees cattle can eat.
Yeah, absolutely. there are many trees that provide either seed pods or leaves that are edible for cattle.
Tell me about what you've done with mine land. I'm in Kentucky, and the eastern part of the state is, I'm sure, has a lot of uh, restored mine land, which is not really restored. It's just, I don't know. Sometimes they plant invasive species in those places.
Yes, they do.
But anyway, tell me about what you've seen and what you've been getting.
Yeah, I mean, the new regulations or the regulations for the past some number of decades has required that mining companies are supposed to strip off the topsoil and stockpile it, so that ultimately when they restore the land, they reapply the topsoil and restore the ecosystem that was there ahead of time. But the reality is that farmers don't stockpile the topsoil, and so that when they go to restore and reclaim the mine site, basically they're taking either overburden that they took off the coal or whatever it was and reapplying that, or ground up rocks from their blasting operation, or perhaps some other subsoil. But there's essentially no organic matter in this surface soil material. There's virtually no biological diversity, and there's virtually no available minerals. So it's essentially barren. So over time, you can get certain invasive species that are typically nitrogen fixing, so that they're basically making, their own fertility from atmospheric nitrogen, and those species often are not edible to animals, and you have low diversity, so very low productivity, and nothing of any commercial value. So one of the reasons that Appalachia is so poor is because of this, that such a large percentage of the region is non-productive. You're not producing any valuable timber, you're not producing any food, and so they're importing food when they should be producing it themselves. So we're working to help correct that situation.
You did some research with the USDA out of college in the area of nutrition. Tell us about the decline of the nutritional value of foods.
Yes, it's becoming more and more well known since I left the USDA. That was about 25 years ago. It's becoming more and more well known that food nutritional value is declining. But when I was there, I wanted to go farther back than typically a lot of research is done comparing food grown 50 years ago to food today, and it definitely shows a decline. But really, we farmers have been depleting soil in this country for, depending on where in the country, for up to 300 years. And so comparing food that was grown 50 years ago with food today might not be all that dramatic a difference. But once you go back 100 years, particularly, and go out west, there was one research study that was done back in the 1920s out in Utah that showed that there was the amount of calcium in wheat, and since Americans eat more wheat than any other food type, and wheat is an important source, should be an important source of calcium. There was a 1,000% difference between the best farmers 100 years ago and the worst farmers, and the amount of calcium in wheat today is identical to the worst farmer in the 1920s. So approximately a 90% reduction in calcium content of wheat today to the best farmers that were growing wheat back in the 1920s. So you can pick anywhere on that spectrum from the worst to the best, but right now the published calcium in wheat is at the same level as the worst farmer 100 years ago. So, this is somewhat of a variable by location. Different locations are going to have different amounts of soil elements, but that's an example of an important, an important mineral that's significantly less than it was 100 years ago. Selenium is another.
What's the solution to that?
It's easy. It's inexpensive and easy to restore, to apply limestone to farmland. Typically, the ag schools are teaching farmers that they need to apply limestone to their farms when the acidity of their soil gets too high. But the reality is that limestone, calcium needs to be applied because it's a crucial nutrient to plants, and it's a crucial nutrient to humans and animals. So it's more than just necessary to affect the pH of the soil.
So you were going to talk about selenium?
Selenium is another element that there's not a lot of research projects back 100 years ago that were measuring selenium, but the ones that I found showed that selenium in wheat back 100 years ago was literally 10 times greater than the amount of selenium in wheat published by the USDA today. And selenium is crucial for our immune system, for protection against viral diseases, and many other factors. It's depleted pretty much across the board in most soil and in most food.
What would you like to change about farming today?
I think that the most important change that needs to happen is that animals need to be moved back out on pasture. The vast majority of meat production, certainly in this country, is by confined animal production, whether it's chicken or hogs or beef, and that has far-reaching negative impacts. The animals are being fed typically corn and soybeans for feed as opposed to grasses, but unfortunately, until soils are restored to a higher level of productivity, higher mineral density, so that you increase protein and improve animal metabolism, then you don't get the animal weight gain and meat quality that is profitable for farmers. So they continue to produce corn and soybeans in a way that over time destroys soil productivity, leads to a nutrient quality of meat that is less supportive of good health than animals that are eating, high quality pasture. Also, confined operations are producing high amounts of manure that are, flowing into rivers and creating eutrophication of our oceans and lakes. Anyway, just far-reaching. Restoring soils so that you can profitably produce animals out on pasture would probably be, increase meat productivity, reduce the pressure on deforestation, and have far-reaching climate and health benefits to everybody involved, and economic benefits for the farmer.
So there's a deeply entrenched notion in the climate conversation today that animals are the problem, that livestock is the problem, that cows burp and produce methane, and but you're saying that cows could be part of the solution, livestock could be part of the solution.
Yeah. Well, one important thing that we need to keep in mind is that humans all around the world crave more protein in their diet. So over the last 50 years or so, the per capita consumption of meat in around the world has doubled. And uh, scientists are predicting that this trend is going to continue and that meat consumption per capita is going to double again. So we can't just sweep this under the rug and say we're going to get people to not eat meat. They're, people crave more protein, more nutrient density in their diet, and meat has more vitamins, more minerals than other types of food. So, this is happening. So our position was we need to find a way to accommodate this craving in a way that is more beneficial to the environment as well as human health. And one of my teachers is Dr. Walter Yenny from Australia, was a scientist for many years at their Cicero research agency, and research that he has done or is aware of shows that actually uh, a pasture with animals grazing on it, where you have green grass and photosynthesis, is actually producing more of the they're called hydroxyl radicals. They're a chemical produced by the grass, actually neutralizes 100 times more methane in the atmosphere than the animals are burping out. So that in his opinion, this methane issue from animals is as long as we're dealing with animals on pasture. Once you shift to animals in feedlots, you don't have that same situation. You don't have that continuous production of the chemicals that are neutralizing methane. So he's actually saying that we need more grass, and you don't get, if animals aren't eating the grass, then the grass just goes to seed, it turns brown, you don't have photosynthesis, and you don't have this neutralization happening. So from his perspective, we actually need more grass and more animals eating the grass, because actually this methane problem is much bigger than just oil wells and animals burping. There's the Russians are saying that we're going to see up to 50 billion tons of methane coming out of Arctic permafrost and the frozen methane in the Arctic Ocean. So he's saying we actually need, an increase of animals out on pasture to help solve this larger methane issue, that they're rather than being the problem, they're actually helping solve the bigger methane problem. And in our case, since we are sequestering typically at least 10 tons per acre, approximately 10 times more carbon in soil than other regenerative farmers, we can also draw down significant amounts of CO2 in this pastured animal meat production situation.
Right. Seems like the media seizes upon the media and the scientific community they narrowly focus on one thing like carbon dioxide or methane, and they forget that this is part of a natural cycle. And what you're saying is that if there's going to be this huge release of methane from Siberia and from the Arctic, then what we need is the mechanisms for resolving that methane, for drawing it down. Those hydroxyl radicals, my understanding from Walter Yen is that it's the OH negative, that you have water, you have sunlight, it splits into a H plus and an OH negative, and that OH negative breaks down the carbon dioxide, it breaks down the methane into carbon dioxide. And if there's ever a big release of methane from the Arctic, we want those systems in place that are going to quickly draw it down.
100%. Yeah.
And then with concentrated animal feeding operations, they talk about using kelp or seaweed to put in the animal feed to reduce the amount of methane. That's legitimizing an industry that shouldn't exist to begin with. The concentrated animal feeding operations are problematic from so many standpoints, not least of all animal welfare. And because they're concentrated, you have to pump them full of antibiotics. The public doesn't want that, but we get it anyway. And you have all these concentration of one species is a vector for disease. So you have to over medicate them with antibiotics. Plus, they tend to be weak animals anyway. They tend to be animals without great immune systems because they're not getting good nutrition, as opposed to animals in a pasture that has biologically diverse collection of grasses and forbs and stuff, and they're getting a lot of the minerals they need. Anyway, don't get me started.
I couldn't have said it better myself, and I'm glad you said it because it's yeah, I've said enough unpopular
Plus, you
things.
have all the manure in CAFOs. You have all the manure being concentrated in one place. By the time you get that, it takes a lot of energy and resources to get that manure to a place where it might be fertilizer. And by that time, it has lost its biological qualities that make it good fertilizer. Better to have the cow doing the work of walking along and distributing that manure in the urine, and then all the stuff that goes along with that. But a lot of oversimplification occurs.
Yeah, we also find in our pasture system that once we eliminate, the dewormers and other chemicals from the system, that dung beetles return to our pasture situation. Mm-hmm. So now, within a few days of the animal depositing the manure, the dung beetles are burying it in the ground where it can add to soil carbon and fertility and remove potential parasites from the next time the animal grazes, so the animals are healthier. Yeah, nature works really well when we keep the nutrients in the system that nature depends on and just observe what happens in nature.
So those dung beetles are fascinating. There's many, many different species. They operate different ways, but like some of them will burrow a hole in the ground and then roll up a ball of dung, drag it down in there, lay their eggs on it. That hole in the ground, for one thing, they're adding fertility down there in the ground. From another thing, that hole is going to absorb some rainwater. But if you give them ivermectin, for example, as a dewormer, then it's an insecticide, and the cow poops out the ivermectin. A butterfly lands on the cow patty trying to get a drink of water. The butterfly dies, and so.
The dung beetles that eat the manure, they're also going to die. So you've killed off all that diversity. Yeah.
So do you expect ranchers to not use dewormers? Do you expect them to just let their animals die from worms or be weak and unproductive from worms? How does that work?
Again, we have to go back to sort of what you might call first principles here. The reason that animals aren't healthy is because they're not getting the nutrients from the forage they're eating, and the forage isn't getting the minerals because the minerals are no longer present in the soil. So, but once we go back, we restore all those minerals, microbial diversity, then the forage has higher nutrient density. The animals that eat it are healthier, and we don't need dewormers. They're able to defend themselves once they have all of the nutrients in their system to do it with.
Plus, I've heard some of them will, if an animal, maybe it's a sheep or a cow, but if the animal gets worms, they might treat them, but then they remove them from the herd so that that gene pool is no longer they're not adding to the gene pool. They're kind of selectively breeding so that they have animals that can survive on their own and thrive on their own in that environment. So
there's
anyway,
a lot of breeding of plant crops, animals to basically accommodate a deficient soil, nutrient density. So our food in many cases has lowered nutrient density, in part because the minerals are not in the soil. But what the seed companies have actually done is they have bred new crop varieties that can thrive in the absence of essential minerals, so that they may not be essential to the plant anymore, but they're still essential to us. So even when a farmer applies the nutrients, if they're using these seed varieties that are bred for low nutrient conditions, the food is not going to contain those minerals. And so it's a pretty significant issue with, so I just can't endorse either animal breeding or plant breeding for low nutrient environment. There's just no substitute for restoring the elements that every organism on the planet evolved requiring.
so how do we get the word out about the environmental and nutritional benefits of what you're talking about?
Well, I think you're probably helping here. It's, I mean, one of the realities is that there's a lot of companies that profit by the fact that crops are sick, animals are sick, people are sick, and so it's only profitable to the farmer, really, for restoring their soil. And so there's a big, there's a lot of momentum toward keeping things the way they are. But, we're working on projects where we can impact ultimately tens or hundreds of thousands of acres, working with landowners and mine owners and business partners, where we can impact larger and larger amounts of land and increase food production and take the pressure off deforestation.
Yeah, exactly. It only makes sense to me to increase the value of the land year after year after year. That should be an attractive proposition for farmers. And by increasing how do you increase the value of land? Well, you have more soil organic matter, you have more nutrients, you have better yields. Soil organic matter is energy, among other things. It's a sponge that absorbs water. All sorts of biological processes can only occur if there's soil organic matter. But the soil organic matter is energy, and there's energy going into it, energy coming out of it. But it's a storehouse of energy, and it only makes sense to increase the value of the land by increasing the value of the soil.
An economics professor at the University of Iowa that specializes on farmland valuation has shown that the value of farmland is 90% correlated with the income that can be produced on that land. So unless you're near a city with development potential, then the value of that farmland is 100%, almost 100% correlated with how much you can produce, which is why farmland in Illinois sells for up to $20,000 an acre, and land in Wyoming sells for $1,000 per acre. So it all has to do with what can be produced on that land. So we're impacting the productivity and how much can be produced on that land.
My guest has been Ed Huling of forterra.eco. Ed, can you share any parting words of wisdom with us? And let's make sure we give people a chance to get in touch with you.
Sure. I think the most important message is that we need to consider forests as essential for combating climate change, and understand the connection between the degradation of soil all around the world and the destruction of soil of forests, and how that's driving climate change. So, certainly we encourage everyone to, to restore soil, reapply minerals, restore microbial diversity, to be able to grow more food and reduce the amount of deforestation that's happening. We'd be happy to hear from you if you have questions or any way we can facilitate that. My email is ed.huling@forterra.eco. So it's ed.huling@4 and then terra.eco. So we appreciate
Sounds
that.
great. Thank you so much for joining me.
Yeah, thanks for the invitation.